יצאנו לדרך? מעולה. אוקיי. אז שלום לכולם. אני אתחיל בעברית ואז נעבור לאנגלית. אז אנחנו במסגרת הוובינרים לקראת IMVC 2026, מאוד 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 שמחים לארח את שיר מאיר לדור. אני תכף אציג אותה, וממש ממש רוצים להגיד לה תודה על זה שהיא קמה מוקדם בבוקר בקליפורניה, ומצטרפת אלינו בשביל להעביר ממש סדנה על ייצור של AI agents. ועכשיו אנחנו נעשה את זה באנגלית, כי זה יהיה מוקלט, ואנחנו רוצים שגם כל העולם יראה את זה. אז hi everybody, welcome to the IMVC webinar, and we are privileged to host today Shir Meir Lador. Shir is now with Google, head of AI, and before that she was group manager and leading also AI in Intuit. She did her master's in Ben Gurion University, where so many talented people came from. We have so many of them in our community, so it's great. So she did a master's in electrical engineering and computers, and majored in machine learning and signal processing. Shir is also a very active member of the community. I think that you were the founder of Women in Data Science Israel, and also you were a co-founder of several meetups, including PyData, and being a co-host of several podcasts. So yeah, Shir, we are so happy to have you. I will now put myself on mute, especially because my dog is dreaming and is making funny noises, and I will let you kick off this session. Thank you.
Thank you so much, Chen, for the lovely intro. And hi, everyone. Super excited to talk to you all here today about building agents and MCP server and all that fun. Chen, by the way, is there a way for me to see the participants, or a way for them
to... Yeah, you
can,
if you click on participants, you can see all the names in the panel. So, but it's a webinar, it's not a meeting, so they can, okay, so they can raise hands, they can ask questions, and I see there is already one question. Thank you for organizing this. Where can I find the recording afterwards? Okay, so we will send an email. I will keep a close eye on the questions, so because you can concentrate on doing your thing, and I will keep an eye on questions and just raise my hand. But guys, you can definitely raise your hands, and we will try to address any questions. So please do that. You have the Q&A and you have the chat. Yeah, so we are people can communicate with us, no problem.
Sounds good. Yeah, because I also like to ask questions during. So is there a way for me to see how many people are raising their hands, for example?
I can, we can, there are polls, but we can ask people to just answer in the chat. I think it would be the easiest, and then we can, yeah.
Okay, sounds good. Okay, thank you so much. So hi everyone, I'm Shir. Today we're gonna learn about agents and how to bring agents from prototype to production. So here's a little bit about my history. I'm not going to talk too much about this because Chen made a lovely intro. Thank you, Chen. In my current role, I lead AI in Google Cloud Developer Relation. That means that what my team does, we basically build samples and create tutorials and teach people all across the world on how to build AI on Google Cloud, which is a lot of fun. I see my current role as something on the border between engineering and education for developers, which is a lot of fun. We also have a podcast, a video podcast, which I really recommend you to follow. It's called The Agent Factory. And we talk about different aspects of bringing agents to production. So if you want further learning, we have a lot of great resources there. So I really recommend you to follow. prior to Google, I was at Intuit for 8 years. I was a group manager of multiple AI teams building AI services to help small businesses and individuals prosper. I also worked at 2 Israeli startups. And as Chen mentioned, I'm very passionate about building communities in the AI space. I did a lot of work around that with PyData, Weeds, the Unsupervised podcast back in Israel. And I also have 3 lovely kids. I moved to California 3 years ago with Intuit. Yeah, I'm super excited to talk to you all today. So if you have any questions, just ask them in the chat. I think that would be the easiest. What will be built today? So we will run through just a few slides to explain what we're going to do and a little bit about the concepts. And then we're going to do a lab 1 and also a bit of lab 2, how much the time permits. In lab 1, we're going to deploy a secure MCP server on Google Cloud Run. And you're going to understand everything soon because you're going to do it yourself. So I hope you already set up your Google Cloud credits. And then we're going to do lab 2, in which we'll build an agent that uses that MCP server. So lots of good stuff. If you have a question, just ask it in the chat or raise a hand, and Chen would help us moderate. And if you haven't already, we have here the links to redeem the credits for Google Cloud. I really recommend you to do this so you can follow along, because this is the idea of all of this. I just told Chen before we connected here that we are actually doing a tour across the world with these materials. We have a few more labs we're doing. We usually do a 1 day of learning in person, where we come to different cities in the US, in Europe, in APAC, and we build with people. So lots of fun, and you get to be a part of it. Super excited. And this is
hello and welcome.
The video.
In this
for
short
the credits.
video, I'm going to walk you through the exact steps to
please
redeem your Google Cloud credit for our workshop. By the end of this, you have a ready-to-go Google Cloud project to complete your lab without needing a credit card. Before we start, there are a few very important things.
I'm not sure that I see your
and this is the most common
video.
You don't see the video?
Did you stop sharing the screen?
No, I'm sharing the screen. So are you not seeing the video?
Oh, maybe I was sharing my screen.
I'm in screen sharing mode.
Oh,
people say they do see it. We see the
mistake that people make is that you must use a personal Google.
Okay, you can see the video.
Like
okay, so it's me.
gmail.com address. A corporate or school email address managed by your organization will not work for this process and will cause errors. So a personal Gmail account is required. And I strongly recommend using a Google Chrome browser in incognito mode. This creates a clean session and prevents any conflict with other Google accounts that you might already be logged into. This is the best way to ensure a smooth process. And finally, you should have received a special link for this event. It will look something like try.gcp.dev/e followed by an event code. If you don't have this link, please reach out to your workshop instructor, or if you're watching this on YouTube or on our website, reach out to me in the comment section. Okay, let's get started. I have my event link copied. And next, in the Chrome incognito window, paste your event link into the address bar and hit enter. You immediately be taken to a Google sign-in page. Remember what I said about using your personal Gmail account? That's what I'll do. After you sign in, you'll be presented with the Google Cloud Platform Terms of Service. You need to check the box to agree with the terms and then click Accept and Continue. Perfect. The next screen confirms that you have successfully claimed the credits. You can see here it says credit claimed. In most cases, the amount is $5. This means the credit is now tied to your Google account. But we're not finished yet. The credit exists, but they aren't attached to anything we can work with. We still need to create a project that can use these credits. A project is like a container that will hold all the cloud resource we created in the lab. To do this, we need to go to the main Google Cloud Console. The first thing we need to do is to create a new empty project. Look at the very top of the page in the main navigation bar. You should see a drop-down menu that likely says Select a Project. Go ahead and click on the project selector. In the window that pops up, look at the top right corner, click the New Project button. Okay, this is where we'll set up the new project for the lab. First, give your project a name. For now, ignore the organization, just give it a name and click Create. It will take a moment for the project to be created. Once the notification shows it's complete, you need to select it. Great, now the project exists, but it's not connected to our credits. To connect them, in the menu that slides out, find and click on Billing. You'll now be prompted that the project has no billing account. This is exactly what we expected. To link it, click to the link that says Link a Billing Account. You should see a drop-down menu, click on it, and you should find an account that names something like Google Cloud Trial Billing Account. Now, sometimes the account doesn't appear immediately. If this list is empty or you don't see a trial account, don't worry, just wait for about 30 seconds and then refresh your browser page. It should appear. Once you've selected the correct trial account, click Set Account. Excellent. The project is now linked. To confirm that the $5 credits is applied, look at the menu on the left-hand side of the billing page and click on Credits. And there it is. You can now see your $5 credit listed and active. Your project is fully set up and ready for the lab. Great, you're all set. Thanks for watching. Enjoy the lab.
Okay, I hope everyone got the chance to do this. And sorry, I didn't copy paste this before, but you all should have gotten the email with this link. Let me just make sure I put it in the chat. Oh, I can't reach the chat now. Oh, there it is. So this is the link to the credit if you haven't got them already. And also the link to the slides. This is the link to the slides. And you also got this in the email. And the link to the first lab is this one. Okay, so now you have all the links. Everything is in the chat. We can get started. Oh, no. Okay. What is an agent? Please, with a raise of hand or write in the chat, did anyone here ever build an agent? And Chen, maybe you can help me if you see people raising their hand because I can't really see the chat at the moment. So please don't be shy, just raise your hand. I see 2 people raising a hand, even if it's a crappy agent, just to let me know. Did you build an agent, any agent? Okay.
Okay.
Okay, good. We have 7 people who build an agent. Anyone tried to build an agent and failed? Okay, I see 3 hands up. Okay, cool. So today we're definitely going to build an agent. These are good news. And in terms of the definition, I'm sure you heard a lot of definition, but this is the one we're going to go by today. This is the most accurate one based on Google, at least. An AI agent is a system that uses a model to reason about and select the appropriate tools to achieve specific goals. So the model is like the brain, say, for example, Gemini, and the tools are like the hands that allow the agent to operate in the real world. So this is the model we will be working with, and we'll demonstrate it soon. So let's build an agent. But how do we build an agent? Let's start with our development environment for the day. We're going to work in the Google Cloud Shell Editor. It is very similar to what you may be familiar with VS Code, but we will be working on the cloud. It will make everything very easy. We will set up the project as Christina showed us in the lovely video. Christina is my peer, by the way. She's awesome. And we're going to set the project, and we're going to work within that. The Google Cloud Shell Editor is an IDE. It has an integrated terminal for running CLI applications like the Gemini CLI. With a raise of hand, anyone here is familiar with Gemini CLI? Not Gemini, Gemini CLI. Very curious about that. I see, 3 people, very little. Well, you're in for a treat. Gemini CLI is super cool. I like to work always with the tab of the terminal open, with the tab of my code open, and with the tab with Gemini CLI when it has all the context of my environment in its context. And it's basically Gemini in my terminal. and it's so helpful. It provides access to the Gemini models, and you can choose, Gemini 2.5 Pro or Gemini 2.5 Flash, or even Flash Lite, whatever you prefer. And it lives in your terminal. It's your like a little helper that can help you do anything you want. So we'll work with that. And it is integrated within the Cloud Shell editor, super easy and convenient, and connected directly to Gemini. The Cloud Shell editor is the one place we will write code and test it. So now to what we're going to build today. We're going to build a little zoo system. Yes, we're going to have our own little zoo. And of course, this is a toy example, but I feel like this is a very helpful demonstration of what are agents and what is MCP and what are tools in a way that everyone can relate to. So we're going to build the IT system for a zoo, a system that helps visitors in the zoo find their favorite animal and get additional information on them very easily in conversational manner. Okay, so let's see how will this system work. In the first lab, we're going to work a lot with Gemini CLI. Is going to function as our agent, and in the second lab, as much as we have time for, we actually build our own agent to interact with our Zoo MCP server. So if we asked Gemini, oh, I see someone wrote could not get the credit, probably because I already have a Google Cloud account, so not a new user. Anyways, I guess it will not be too expensive. Yeah, it definitely won't be too expensive. It's, the credits we give you, it's like less than, it's a $5. And like when you run everything, you maybe, it costs you like a few cents. So no worries if you already have an account. By the way, you should be able to get an account with the credits, even if you already have one. You just need to use your personal Gmail account. Otherwise, it wouldn't work. So note that, Ron, if you tried it on your business account. Anyway, so I have a question to you all. What do you think? If I asked Gemini about the penguins in my zoo, I asked it, where are the penguins? Would Gemini know the answer to that? What do you think? You can answer in the chat, or you can raise a hand and we can let you answer. I see one person is raising a hand. Kobe, do you want to answer? Or is it a legacy hand? Chen, you are muted.
Yes, I'm looking for Kobe, because you saw that Kobe raised his hands.
Yeah, I'm just looking at the participants. I see one person raising a hand. Maybe it's a hand that is up from before.
Yeah, but because I don't see.
I see Ron is answering, guess it has no clue about your own private penguins. Exactly. And that's the answer I was looking for. Gemini is a super smart, talented model trained on lots and lots of data, but it has no idea what happens in my own little zoo, right? So when we ask Gemini CLI, it basically goes to Gemini, as I said, and try to gather information for that question. And if it doesn't have enough context for information, maybe it's going to hallucinate, maybe not, depends on the model. Maybe it will realize, I don't have information about your zoo. It also depends on how you ask the question, right? If you ask him not to hallucinate and ground in real data. So yeah, thank you for the answer, Karina. Okay, so this is the model that we are using today. As I mentioned, we're going to use Gemini 2.5 Flash. And let's, okay, sorry, I went too fast. Does Gemini know where the penguins are in my zoo? No, it doesn't. And that's why we need to provide Gemini with additional context about our zoo. And how will we provide Gemini with more context? We're going to use tools or MCP servers that will provide us access to those tools. So that is what we're going to build here today with Lab 1, the MCP server of our zoo. MCP is the Model Context Protocol. It basically extends the capabilities of our large language model with additional information, with access to different APIs. Our MCP server, the one we will build today, it will provide Gemini with a tool to find animals in our zoo by species and a tool to find specific details about an animal by its name. So this is how our MCP server is going to look like. It's going to be a very simple one. It's going to have one tool of get animals by species and one tool of get animal details. So when we're asking Gemini, where are the penguins? Gemini, when we connect it to the MCP server, will understand that, hey, I don't have information about this zoo. I need to call the zoo MCP server to get that additional context. Now, the next question is, how does Gemini know which function or which tool to use within that MCP server to answer this question? Does anyone has any thoughts about that? If you built agents before, maybe you know. How does Gemini know which tool to use given a certain question or prompt? Any thoughts? You want to throw it in the chat? You can define it. Good, but how do you define it? Okay, let's semantic search. It has description. Yes, this is the answer. So from the description, thank you. Who said that? Oz. From the description of the tool, Gemini can determine which tool to use. And you will see it in a minute when we're going to build that MCP server. This is, for example, the get animals by species tool that we will define. And we're going to use FastMCP. We're going to see that very soon. And the get animals by species has this description here. So Gemini basically reads the description and understands that this is the function it needs to use to answer this question. So thank you for the great engagement in the chat. Really appreciate it. I wish I could also see your faces, but you know, this is better than nothing. Yeah, this is great. Okay, so the Gemini CLI will understand that it needs to use the get animal by species from the server zoo, the MCP server of the zoo. And then it will ask us for permission, because this is how Gemini CLI operates. It asks for permission to execute tools. Then we will say yes, and then it will call this tool. The tool will basically bring us back all the information it has about the penguins in the zoo. So this is raw information. It will come in the form of this kind of a dictionary with all the penguins and all the information it has on them. Now, Gemini is interacting with a person, so it want to answer in a conversational manner. So it will basically take this raw information and convert it to a proper answer for us. You can find the penguins in the Arctic exhibit on the polar path. So this is it. We completed the whole loop of lab 1. And in lab 2, we're actually going to build this agent. We're not going to use Gemini CLI. We're going to use our own agent and call this name MCP server. So let's build this. Now I'm going to have to figure out how to share a different screen. And you will have to open this link. And I see Chen also pasted it once again. But you just saw it. It's a very easy, short link. And I'm going to try and share a different screen. Let's see. Okay, you see Google Cloud Shell. You see how to, oh yeah, great. This is working. Good. So I hope everyone has access to lab 1. And by the way, all of these labs were written by my team and our parallel team. We all kind of work together to bring the most interesting concepts here to practice. And if you have any feedback or thoughts, feel free to share it with us after. In this lab, we're going to build a model context protocol MCP server, which is, as we said, provide LLM with access to external tools and services. We will also do it in a secure manner, which is actually something we heard a lot from developers, is how to do it securely. So not everyone can just hack my MCP server and overstress it or DDoS it. And then we're going to connect to the remote MCP server from the Gemini CLI. We're going to deploy the MCP server to Cloud Run. We're going to secure the endpoint by requiring authentication for all requests. We're going to connect it to Gemini CLI. Okay, so in terms of setup, you should all have set up your Google Cloud project with the credits by now. And now the next step is to open our development environment, the Google Cloud Shell Editor. So please do that. You have the link here in step 3, here in number 1. And this is what's supposed to happen. I will leave this one and let this one. Okay, so this may take just like a minute or two. Sometimes it's slower, sometimes it's faster. I don't know why it's so slow now, maybe because everyone is doing it at once. Okay, now we got this thing, and then open folder. So I'll just gonna open my home folder for my user. It's supposed to be empty. I played around with it, but I deleted it. Okay. And just out of like convenience, how I like to work is I like to start a terminal. I'm just going to show you once how I do this in terms of the setup. I like to start a new terminal here, and then you can do move terminal into editor area. I already have it here, you see. I have a few terminals here, but I don't really need all 3. I usually use like 2. And the reason is that I usually use one just with a regular terminal, and the other one would be the Gemini CLI, as I mentioned before. How do I open the Gemini CLI? And we'll use Gemini CLI in 2 forms today. So one would be as the agent that calls our MCP server, that's one. And the other one would be to help us debug if we get any issues. And you'll be surprised, but sometimes I get issues in the live demos because things change, dependencies change. So Gemini CLI is super, super helpful for debugging everything for me. I just tell it, oh, this is the error I'm getting, and yeah, so this is Gemini CLI, and you can just converse with it and ask questions, and it's super fun. And if it asks you to authenticate, you can just authenticate with your Google Cloud, with your Google account. That's the easiest way to do this. You can also get a Gemini API key, but it will take you a bit longer. So this would be the easiest way to go. So I see someone has issue with the link. Yeah, I'm not sure. Yeah, I think you should have all the links in the email. Yeah,
I'm forwarding the email. Maybe people missed the email that you have sent with all the details, so I'm just forwarding it while we speak.
Awesome. Thank you so much, Chen, for figuring it out while we go. Okay, so let's get started. We need to first set the project we are working on. So we're going to do this in the terminal. From now on, we work on the terminal. So there it is. I'm just going to write in the terminal gcloud config set project, and then I need to put there my project ID. Oh, but how do I know what is my project ID? So that's a great question. So let's just go to the Google Cloud Console. And I have a few projects here. You see, this is my list of projects. How did I get here? I just press here. You just defined a new project for this with the new credit. And if you want to see what is the project ID, so you can set it in your terminal, here it is right here. You see, for me, it's called IMVC test. So just use whatever ID you have here. I'm just going to copy paste this. If it's challenging for you from any reason to do this, by the way, I just did it and it says updated property. And now you can see I have the IMVC test here. By the way, is the font size okay? I guess everyone can increase the size if they want in there. Do you need me to make it bigger? Or?
For me, it's a bit too small, to be
so
honest.
Now, is it better now?
Yeah, now it's perfect. Thank you.
Yeah, of course. Okay, anyway, if you're not sure, you can also do this, this command and this line after the example here, the one that does list. So this one will tell you all the projects you have on this environment. So you see, I have these projects and I chose to work on this one, which is dedicated for this workshop. Okay. Now we're gonna enable the API. This is step 4. So enable the API. This is basically telling Google Cloud, these are the Google Cloud products or services we're gonna use today. So we're gonna enable the Google APIs. This basically enables Cloud Run, what we will use to deploy the MCP server. It's also enabling artifact registry. This is where we're gonna store the container image we will create. And Cloud Build is the one that will help us build the code that we're going to write today. And then this is supposed to take, just a few seconds and then finish successfully. And Chen, I'm counting on you to tell me if there are any issues with someone. Okay, now we're going to create.
Yeah, just a quick question.
Yes.
Can you send me the link to the Cloud Shell editor? So this also can be resolved with the email, or?
Oh, this is in the step 3. You have the link.
Okay.
Open Cloud Shell editor.
Okay.
So everyone should be able to access it from here.
Mm-hmm.
But also, if you just go to Google Cloud and write shell, it will also find it like this. Yeah, okay. So let's create the folder for our MCP server. So this is basically creates the folder and gets into it in one command. It makes the directory and it goes into that. Right now, this directory is empty. We just created it, but we're going to add the code. And we're going to use something called UV to handle dependencies here for this project. The UV tool creates a PyProject2ml file. It's basically, if you work with a PEEP in the past, so it's like a requirements text. It's pretty similar. It's just a little bit more efficient. So let's create this new project here. Just by copy pasting should be very easy. And sorry, okay. Now let's look into our PyProject2ml file. So this is what we have in this file. We can also, let's see where it is. Okay, in our MCP on Cloud Run folder, you can find, I went here, by the way, and then I found our folder, and you can also see this is the PyProject2ml, which is like the equivalent of requirements text. So right now, it basically has just a definition that we need Python with this version. And now we're going to start writing the code. So first of all, to create the Zoo MCP server, we're going to use a very, very powerful package called FastMCP. And this is basically a standard framework for working with the model context protocol. It will basically allow you to write any MCP server that you want and create all the boilerplate code required to have it standardized. Because what is MCP? It's basically a standardized way to create APIs that agents can interact with. And FastMCP will do all that work for you. So what we're going to do, we're going to copy this line and run it in our terminal. And what it's going to do, it's going to add FastMCP in this version to our UV defined dependencies. So now if I check out my PyProject2ml, you can see that I added FastMCP. Okay.
And here, I just don't want so there are two people, I just don't want them to be left behind. So Shachar is asking whether theoretically you can do all of that with Google Colab Notebook, server and agent, instead of using the Cloud Shell. Is that correct?
So you could do some of those things on a notebook, but I must say it's less recommended to use notebook for deploying servers and all of those things, because you usually want to work with code and with the terminal to create a more reproducible production environment. So notebook for my end is more helpful for kind of prototyping and debugging. But today we're trying to build something that is actually deployed and is like taking the first steps on the direction of production. So the answer is yes, you could do it with a notebook, but I wouldn't recommend it.
Okay. And Ofer is asking where is the MCP server. So I thought that, yeah,
we're going to build the MCP server. That's a great question. Yeah, we're going to do it very, very soon. Okay, so this is exactly what we're going to do now. We're going to define our MCP server. And so this command here in number 2 in step 6 is going to create this server py file, which will basically be the code of our MCP server. So what we did in that command, the command is cloud shell edit. With the path to server py, which is just a Python file within the folder MCP on Cloud Run. And it creates the file and opens it for us. And now we're just going to copy paste all of this code, and I'm going to break it down with you. Don't worry, we're going to explain everything. And this is our MCP server. So again, I just copy pasted the server py code and into our server py that we just created. Okay, now let's go through this code. First, we're going to have a few imports here. Async is going to be able to run our server in an asynchronous manner, so it will be able to get multiple calls at once. And we're going to import a few basic things like logging and list and dictionary and fast MCP, as we mentioned, because this is the one that's going to help us define our MCP server. And here we're going to initialize the fast MCP server. This is basically the initial instance of our MCP server. And then instead of building like a full-on database, as I said, we're trying to simplify things just to understand the concept. So we're going to create a dictionary with animals at the zoo. So this is our dictionary with all the animals. So it's basically a list of dictionaries, and each of the items here is one animal. It has a species, a name, age, enclosure. It's where it is in the zoo, and trail is how to get there. So we have lions, we have penguins, we have elephants, and all sorts of wonderful animals. And one of the challenges I would tell you all to do, if you kind of figure it out very, very quickly, you can try and add new animals to our zoo and see what happens. So that will be the challenge after we kind of make this work for the first time. And then after we define this dictionary, we define our tools, which in our case would be very simple functions that use this dictionary. So as we saw in the first presentation we have 2 tools here. And again, an additional challenge for you all would be to add more tools to this MCP server later to see that you understand how this works. So one tool is the get animal by species. That's the one that will help us answer questions like, where are the penguins? It basically gets the species and finds all the information that we have about that species. So where are the penguins? Returned all the information about all the penguins. And you can see the description here, as we said, the one that helps the agent, the model, figure out which tools to use. And then we have get animal details that, given the name of the animal, it provides us the information for that animal. So these are the 2 tools. And as you can see, these are just very basic functions with this decorator from fast MCP that tells the Python that this is basically the tool in our MCP server, this decorator. MCP, we created it in the beginning. If you remember, this is MCP defined by fast MCP. So this is it. This is our MCP server. We still need to deploy it, and that would be the next step.
Shir, just a quick question. I
this
see that one of the Alexandra cannot see the screen. I just want to make sure, is this a problem also for other people? So if you can't see the screen, please raise your hand, because I can see the screen. I don't know why Alexandra cannot see the screen. So, okay, so Alexandra, let's try to resolve it between us, because the rest of the people I see, they can see the screen. So,
okay, you're muted now. Okay, good. Okay, so here we basically, in the main part of our script, we run our MCP server using Asyncio. Okay, so this is the code for the MCP server. Now it's the time to deploy the MCP server to Cloud Run. We're basically deploying it to the cloud. We want to have an accessible URL for this MCP server so anyone can call it, and not just within our code. So to do that, we're going to create a Docker file. We're going to go back to our terminal and create a Docker file in the same manner how we created the server PY. We're going to create a Docker file and just copy paste all of the code we have here in step 7 into our Docker file. And remember, the Docker file needs to be on the same folder on MCP on Cloud Run. This is how we created it. And what the Docker file does, it basically creates our container image to run on Cloud Run. We're going to use the official Python image. This is like very slim, basic image. On top of that, we're going to install UV, which is the one that allows us to manage dependencies for our project. We're going to install our project into app. And then this command allows the statements and log messages to immediately appear in the logs. And I'll show you later how you can actually view the logs. It's also in the lab. And then we're going to install all the dependencies by doing run UV sync. We're going to define this is the port that we're going to expose the MCP server in. And this port, the dollar port, is going to be defined as an environment variable. And then we're going to run the MCP server with this command. Okay, so now we have a Docker file. And let's try and deploy our MCP server. So this command basically just makes sure we are in the right folder. It's very crucial to be in the folder where the Docker file and the code is to deploy it. And let's just copy paste and run it. So while we do it, I just ran it. You see it will ask us that it's going to require artifact registry Docker repository to store the build container. We're going to say yes to that because we need to store the image in artifact registry. This is one of those APIs we enabled in the beginning, if you remember. And you can see the command is very simple. This command basically builds our code and stores it in the artifact registry and then deploy it on Cloud Run. You can see it says gcloud run deploy zoo MCP server. This, by the way, takes just a few minutes. No allowed authenticated. Anyone knows what that means? We talked about it. We mentioned that before. Let's see if there are any comments in the chat. Anyone knows why are we doing no allow authenticated in the deployment command? Security, thank you, Shai. Good engagement, exactly. So we don't want anyone to be able to access our MCP server. We only want authenticated services to call it. Oh, and look, our MCP server is live and serving 100% of traffic. That's great. Let's see how we can try and call it now. So this is what we got. Hopefully all of you are going to get that soon. And now, before I continue, I'll just wait a moment to make sure everyone got this. I'll just explain the next step, which is we talked about security. And we mentioned that we want Gemini CLI to be able to call our MCP server, right? Like we saw in the deck in the beginning. So to do that, we want to give our user account permission to call the remote MCP server. So we're going to use this command, the gcloud add IAM policy binding, and this is how we manage security policies on the Google Cloud. We're basically going to grant our service account the role of invoker of our MCP server. So this is the command I'm going to run now. By the way, who has their MCP server deployed by now successfully? I'm very curious. Maybe you can raise your hand to indicate that. I see 3 people, 4, 5, 6. I got an error. Oh no, Shai, what error did you get? Do you wanna copy paste it here? Error, build failed, check big logs for details. Oh, that's very interesting. So how do we check the logs? You probably have a link there, but you can also just go to Google Cloud Console. And this is very useful for everyone, not just for Chai. I had to detach and listen. I learned theory mode. Okay. That's cool. Whatever works for you. So what I did is I went to Google Cloud Console, and then I wrote here in the search Cloud Run, and then I went to Cloud Run, which is our application platform, our serverless deployment area, and here I can see the status of my server. My server is green. I have the URL here. But you know, if you got an error, then you will see it here and it will be red. And then you can see here the metrics for the server. Right now, nothing happened because we haven't used the server yet, but after we will call it, we will see data here. And you can see the logs here. So Shai, what I recommend you to do is try to look at the logs and see where was the failure. And then I would recommend going to Gemini CLI and copy pasting the error and asking Gemini CLI what is the matter. And of course, like the most obvious thing I usually do, it's empty, there's no service. Okay, so there might be also a link to the logs in your in your terminal. When you try to deploy, there might be also linked to the logs because they were error, like I have here. You see logs are available at. So you should have something like that. And that would, what I would usually do, just try to copy paste the error log, give it to Gemini CLI and ask, what's wrong? Can you help me? If you don't find it, then you can also just and most importantly, when you interact with Gemini CLI, do it from the folder that you're operating on, so it will have the right context. So for example, here, I was just generally in my user space. So now I'm going to get into my folder, MCP on Cloud Run, and then I'm going to run Gemini. And then it will have the context of the current folder. So it could look at the files and see what's wrong. Maybe you have some typo or whatever. The most common things that happen in our workshops that we run all across the world, usually people are able to complete all the labs with no issues. But if they have any issues, I just tell them start over. Maybe you missed a step. Maybe you rewrote the code, you know, you had some bug inside. So this is what I recommend you to do, Shai, but also, you know, use Gemini CLI. It's super helpful to detect those bugs. It's super helpful for me as well. Okay, so we'll move on. So we'll have time to do more things. So the next step is, as I said, give your user account permission to call the remote MCP server. Let's do that. Okay, so we're seeing this. It means that we updated the IAM policy for our project to be able to call our MCP server. And now we're gonna save our Google Cloud credentials and project number as environment variables for us to use in the Gemini settings file. So we also need from a Gemini CLI direction, we need to define how to connect to the MCP server. It needs to know where to search for it. So for that, we're gonna define the two environment variables, the project number and the ID token for the authentication with the MCP server. And the next step would be to open the Gemini CLI settings file by doing Cloud Shell edit Gemini settings JSON. So this is basically, this is before, because I ran this before, but I'm going to redo it now. We open the Gemini CLI settings file, and then we replace the Gemini CLI settings file with this content here, which basically gives it the URL of our MCP server, the one we deployed, and then also the ID token that recognize our service account. So I'm going to delete everything inside if you have anything in there and just copy paste this code. Yeah, let's see. Is everyone with me? Do you have any questions so far before we try to call the MCP server from Gemini CLI? Yeah, just feel free to write it in the chat if you have any questions. And hopefully most people were able to deploy their server. And after we define this settings JSON document, by the way, if sometimes Cloud Shell edit doesn't open the file for you, it's because of cookies thing. So you can also find all the files here. And since some of those files that are hidden, you can go to view and do toggle hidden files. So this will show also hidden files, the one that start with the dot, like the .n file and things like that. So this is just a tip. Okay, so now after we define, I'm on track running it in my mind. This is a great workshop. Okay, thank you, Ori. Let's start the Gemini CLI in this terminal now, after we gave it access to the MCP server. And let's see if it worked, if Gemini CLI actually recognized our MCP server. So I'm starting a new one here in this tab because I gave the access to the service account from this tab. So the other one wouldn't work because it's not defined, it's not authenticated with my project ID. So just a note. Okay, so now my Gemini CLI started. So a very easy way to see all the MCP servers that are available is just to write here /MCP. Oh, yes. So we can see here that we have the Zoo Remote MCP server here and it's green. So if you're seeing this, this means you're all good by now. You have deployed your MCP server and Gemini CLI is able to recognize it. Now, there is a chance that you may see the Zoo Remote server and it will be red. Well, this means that maybe you haven't configured well the Gemini CLI, the MCP server in your Gemini CLI settings, or that you haven't given access properly to Gemini CLI to call your MCP server. So in that case, I would recommend you to redo these steps, like in all of number 8. And then get out of Gemini CLI, redo the steps and get into Gemini CLI. And of course, check that your MCP server is deployed successfully. If you're not sure, as I showed you before, you just go to Google Cloud Console, search Cloud Run, and then you see all the servers that are deployed successfully. Okay, so I want to ask Gemini CLI a question and see if it's able to answer, to reach the data of my zoo. So let's start with this very simple question that we also saw in the beginning. Where can I find penguins? Okay, now what Gemini CLI would do is would search for that information, would realize that he can use the MCP server for that. And then it asked me for permission to call this tool, get animals by species, allow execution of MCP tool, get animals by species from server zoo remote. And I will answer 1 or 2 or 3 or 4. And in this case, I will say, I want to allow all tools from this server. Then you see here the MCP server returns all the information it has about the penguin. This is the raw data. And then Gemini CLI translate it to conversational matter. You can find the penguins in the Arctic exhibit on the polar path. Yay, success. So if you've gotten so far, this is great. You have a working MCP server. You're able to connect to it from your Gemini CLI. Okay, thank you for the feedback. And now you can, let's maybe, I got an error. Oh, what error did you get? Resource exhausted. Please try again. I'm not sure what is this error about. It sounds like maybe there is some issue with Matania. Do you have an existing Google Cloud account or is this a new fresh one? A new one. Interesting. Yeah, I'm not sure what this error is about. I would consult with the Gemini CLI and try to debug this. And maybe, just start over and see if that works. As I said, usually things work if we do it step by step, but sometimes we miss things. Okay, let's see what goes next. And this is the debugging we talked about. What happens if we don't identify the zoo remote? Okay. We saw how we can see the logs for our MCP server from the Google Cloud Console. We can do it. Oh, Zoom is annoying. Okay, we can do it from here by going to our MCP server and then going to the logs. And then you could actually see the tool that were used by our MCP server, the tool get animal by species called for a penguin. Okay, we can also see the logs just by running this gcloud command, gcloud run services logs read to MCP server in a region. And then if we just exit, by the way, to exit from Gemini CLI, you can either do /quit or do Control-C. That's what I like to do. It's the fastest. Control-C. And then I will just run the command to read the logs. And you can see the same log as we saw through the console that this tool was called. Another thing we could do as an optional step is to add the MCP prompt to the server. So that's basically like adding a shortcut to our MCP server to, instead of asking it where are the penguins, we can just say /find penguin or /find lions, and it will find us where all the lions or penguins in our server. So this is what this prompt defines for us. And to do it, we just copy paste this code, go back to our server py file that is in our MCP on Cloud Run folder. And right before this, the main part of our server py, we add this new piece of code, the find animal prompt, which is, again, just a shortcut for us to be able to run those commands quickly. And I want to challenge you, as I said before, to write your own prompts and write your own functions. For example, one of the tools that I think is missing here is, hey, how many animals do you have in that zoo? or how many types of animals they have in that zoo. So you can easily write another function here and just add this decorator of the tool, and then redeploy the MCP server, and see that you now have additional tools. And you can also test this prompt after you redeploy by just typing find lions or find lions in Gemini CLI.
Shir, there is a question from Uri.
Yes.
What is happening behind the curtain? Is it the LLM fine-tuning, transfer learning, or no training at all?
Oh, there's no LLM training here at all. What we basically do is we use Gemini, which is API provided by Google, and just connect it to our MCP server. We just give it access to our MCP server. That's it. That's the fine beauty of this MCP, the Model Context Protocol, that you don't need to do any fine tuning with your own data. You can just give it access to your data. Yeah, thank you for the question. Can I write all of this locally in my VS Code instead of Cloud Shell Editor? Yes, the answer is definitely yes, Ron. The only thing you need to do is install gcloud commands in your local environment, so you can run all of those gcloud commands that you see here to make the deployments. But definitely you can do all of this locally. Okay, so if we want to see that this in fact works, we need to redeploy our application to a Cloud Run. So let's quickly do this here. And after we do the deployment, every change we do in our code to make it take effect, we will need to run the deployment again. And then we will also need to refresh our ID token for the remote MCP servers. So we will still be authenticated and would be able to call it from Gemini CLI, and then run Gemini CLI again. And then we can test the prompt, the shortcut that we created for find animals. And this is the test that we can run. So while we wait for this to deploy, let's skip to the next step also. Another thing we could do is to use Gemini Flashlight for faster responses. So as we mentioned in the beginning, Gemini, the Google LLM developed by DeepMind team at Google, has multiple versions. It has 2.5 Pro, 2.5 Flash, and also 2.5 Flashlight, which is even lighter and faster model. And for these basic operations, like using tools and just synthesizing their outputs, sometimes it's enough to start with a very light model. So we can run Gemini CLI with this lighter model by running this command, Gemini ---- model, and just defining the version that we want. And then you can see the response would be much, much faster. So let's try that. Let's try Gemini CLI, but this time we finished the redeployment after the prompt we added. And now we are running Gemini CLI, this time with 2.5 Flashlight. And now let's try to find the lions by writing /find lions. Now we're using the prompt we created in our MCP server. And again, it figures out that what we want is to find all the lions. It asks us for permission. Because I restarted Gemini CLI, it asks us for permission again. And it gives us all the information about all the lions. As you can see, the information is given in a bit of a different way this time because we're using a different model. Just lists all of the different lions we have and where they are located in the zoo. But we got our answer. Okay, let's see. In terms of debugging, we can see, okay, that this is the same thing. Okay, so Conclusion, we have successfully deployed and connected to our secure MCP server, and we still have a little bit more time so we can start running through the second lab. So let's do that because I'm really excited about the second lab. Don't do the cleanup steps now because we're going to use the MCP server in lab 2, but definitely go through the cleanup later after you're done playing with all of this. And I really recommend you to play with all of this. As I said, you have some optional challenges I gave you. So in the second lab, we're going to build an agent that is going to call this MCP server. And we're going to learn how to build a project, a Python project for ADK deployment. Google ADK is the Agent Development Kit. It's going to be the framework, open source frameworks that is developed by Google that will help us build our agent. And we're going to connect it to our MCP server. And we're going to deploy the agent to Cloud Run. And you can read more about Cloud Run, but basically is a great choice for hosting agents and LLM applications in general. What's wonderful about it is that it's serverless platforms. So we can focus on the code and not managing the underlying infrastructure, and it handles the operational work for us. It's like a pop-up shop. It pops up when a lot of people come, it operates. When there's no one there, it just turns down. So you don't pay when there's no usage. Really, really nice. And all of this setup part we don't need to do because we already did it. We already set up the project. And we do need to enable the APIs because we're going to use a few additional APIs here. So I'm going back to my terminal. I'm just going to do cd ... to get out of the MCP server because we're going to work on a new project. And I'm going to enable the APIs. And again, I'm still working in the same project we worked before. And now I enabled a few more APIs. I think the main addition is that I am now also using the AI platform, which allows me to call Gemini from my agent. So this time we're not going to use Gemini CLI to call the MCP server, just our own agents. Okay, now we're going to create the Zoo Guide agent with ADK. So for that, we're going to create the new folder and get into it. The new folder is currently empty. It's called Zoo Guide agent. And now this time we're actually going to use PEEP just because two different people created this. We need to actually be standardized, but we're going to create a requirements text document and add the dependencies for our project. So these are our dependencies, very easy. The Google ADK with this version, launching community and Wikipedia tool, because in addition to using the MCP server from Lab 1, we're also going to use Wikipedia tool. And we're going to show you all about it. It's going to be very easy. We're going to define a few environment variables with our project ID, the project number, and the service account, and just to make it easy for us to have this information stored in a secure manner and not within our code. Then we're going to define a .env file. This will help us authenticate our agent with the MCP server. Now we need to authenticate our own agent. Like before, we changed the settings for Gemini CLI for the authentication. Now we need to do it for our agent. So for that, we will define in the .env file, we will define a few environment variable. The model we're going to use is Gemini 2.5 Flash. And with our service account, the one that we will have to give the role of invoker of our MCP server, like we did for Gemini CLI. In the next step, we're going to give the Cloud Run service identity permission to call the remote MCP server. So this is very similar to what we did before. G-Cloud project, add IAM policy binding project ID. And for this service account, the one we just defined, we gave it access to our MCP server. And now we're gonna save the MCP server URL from lab 1 to an environment variable. So this is what's going to tell our agent where to look for the MCP server. And so this command does two things. One, it brings us the MCP server URL, and then it adds it into our .env file. So now if I go to my .env file, you see that I have the MCP server URL here, the one we created in lab 1. I hope I'm not going too fast. I'm just trying to make a bit of progress so we can go through this. If you have any questions, feel free to just put them in the chat. The next step is we're actually going to build our agent. So the first thing we're going to do is to create an init.py file in our folder. This one just tells Python that the zoo guide agent, okay, I'll slow down. So we're going to create an init.py file. This one tells Python that the zoo guide agent directory is a package. So again, we are in zoo guide agent folder. We only have requirements text here that defines our dependencies. And we're going to create an init.py file. And in the init.py file, we're just going to have one line from .import agent. So just copy paste this from .import agent and put it in the init.py file. That basically tells Google ADK, hey, this is where our agent is. This is where you can get all the agent functionalities from. That's it, very simple. And then the next step would be to write the code for our agent. Again, this is a very simple agent we're going to use today. And let's start working on it. So what we will do is just Cloud Shell edit agent py. This again creates the agent py file in our zoo guide agent folder. And in the agent py, we're going to copy paste this code. And this code is now broke down into a few parts so we can go through it. So step 1 is imports and initial setup. So if you look at the code, it just brings all the necessary libraries from Google Cloud and from ADK. It also sets up logging, loading the environment variable from .env file. This is very important. This library called .env has a function called load.env. And it runs here, load.env, and this basically brings all the environment variables we defined in the .env file into our container. And this is crucial. We need those environment variables to access the model, the Gemini model that we defined, and the server URL, the MCP server. So let's copy paste this and just put it here in agent py. You see here we define the model name. It will take it from the environment variable model that is defined here in our .env file. That's Gemini 2.5 Flash. Hopefully most people are able to follow. The next step is defining the tools for our agent. An agent is only as good as the tool it can use. This is the way the agent can operate in the world. In this part, we will define all the capabilities our agent will have. We will have a custom function to save the information, the prompt. We will have an MCP tool that connects to our secure MCP servers. So if you know a little bit about MCP, it's a basic client server architecture where you have the remote MCP server, the one we created, and then you need to define an MCP client that talks to that MCP server. So that's what we're going to do here. And we're also going to define a Wikipedia tool. So let's copy this code part and add it here right after the model name, and then let's look at it. So I'm going back up. We were here at model name. So the first thing we do and we will understand the architecture here in a minute. We're going to greet the user. And again, you'll see the agent and how it all comes together soon. So we're going to have this weird function here that says add prompt to state. We're going to save the prompt of the user, like where are the penguins, where are the lions, show me the way to the giraffe. We're going to add it to the state of the agent, because we're actually going to have a multi-agent system. So multiple agents are going to work together to help answer our question. So everyone would be aware of the context here. We will save it in the tool context by the prompt key. So that will be the first step. And then, so this is a tool that our agent will call and save the prompt into the state. Then we're going to configure the MCP tool to connect to the Zoo MCP server. So this is the MCP client, basically. It takes the MCP server URL, the one we defined in our .env file. Remember this one? So it calls it by using OS get environment variable MCP server URL. So it takes that, and then what it needs to do, it needs to authenticate, right? Remember that point? So to authenticate with that MCP server, we need to get the ID token. So this is what we do here. We get the ID token, and then this is the actual MCP client, the MCP tool we are defining here. It takes as parameters the MCP server URL that we got from our environment variable, and it gets the ID token for us to authenticate with the MCP server. So this is it. This is how we call our MCP server within our tools. And we also add another tool here, the Wikipedia tool, which is basically a given with LangChain. You just need to import it. As we saw in the beginning, we import the Wikipedia tool. What's nice about the Google ADK Agent Development Kit is that it has those wrappers around LangChain tools, that you can use LangChain tools within Google ADK just by using this LangChain tool wrapper. So super cool. You can basically use any tool that is developed by the LangChain community within Google ADK just by using this LangChain tool wrapper. So hopefully you're all getting this. In class, it's way easier because I see people, but I'm trying to go not too fast. And this is just the explanation of the three tools. And now we're going to define the agents themselves that are going to use those tools. Okay, so we're going to have a researcher agent. This is the one that does all of the main part of the work. And the researcher agent, you can see this is the description for it. It accesses both the internal Zoo data, that's from our MCP server, and external knowledge from Wikipedia. These are the two tools it has at its disposal. And we also tell him that it needs to analyze the user prompts. And this is a way to tell it to get the prompt from the state, because in the beginning, when the chain starts, you'll see that we will add the prompt into the state. And we also mentioned here how the prompt is stored in the state. We define the tools and we define the output key. So basically, after the researchers does it work, it stores it in the context under the key research data. Then we have additional agent. And again, there are a lot of agents here, and this is mainly to kind of demonstrate the concept of separation of concerns, that each agent is focused on one very specific goal. So one is only doing the research, And the other one is only doing the response formatting. It takes all the info. This runs after the researcher. It takes all the information and synthesizes it into a friendly, readable response. So this one basically gives the personality to our agent. It takes the research data from the context and returns it in a nice conversational manner. And I want to challenge you to make it even nicer and also change the code later after we deploy it. Or after you deploy it, and make it, for example, tell a joke about the interesting fact that it just shared about the animal that it was asked about. Okay, so I'm going to copy those two agents here. The first one was the researcher, the second one was the response formatter, and hopefully this is very easy for you all to understand, because those agents, you can see that it's simply defined. You have the name, the model is Gemini 2.5 Flash that we define, description, instruction, and here you also have the tools, the MCP tools and the Wikipedia tool. Of course, you can define more tools. Okay, the next step is to define the workflow agent. So this is actually not an agent. It doesn't have a model. This is just a workflow definition that defines that one agent runs before the other. First, we run the researcher, then we run the response formatter. So again, we're just showing you lots of ways, lots of models you can use to build agent. This one is sequential workflow. And you can see there's no model defined here because we don't need an LLM to do this. We just need to call one agent and then call the other one. So this is the workflow. And the final step is to assemble the main endpoint of the agent, the greeter one. So we basically have three agents here. The greeter one that we're going to write now, that one calls the researcher and then the presenter, the response formatter, we called it. So this is our root agent. Let's copy it and paste it also in the same place. So again, we just copy paste all the code one by one and no secrets here. And we can make changes later. The root agent, its whole purpose in life is just start the process, greet the visitor in the zoo, and let them know that you will help them learn about the animals we have in the zoo. And when the user responds, just use the add prompt to state, the tool we defined, the weird tool we defined in the beginning, to save their prompt, what they're looking for. For example, the prompt would be, oh, where are the penguins and what do they eat for lunch? Something like that. And then, it might need to use only the MCP server. It might need to use the Wikipedia information. And then it will transfer control to the workflow we generated, which runs the researcher and the response formatter. Okay, so we finished our code. Now let's prepare our application for deployment.
We are almost reaching 8 o'clock here. So
yes.
Okay.
Okay. Hopefully we can at least deploy it before that, and then you can test it later on your own. Yes, we're doing a lot in one day, but that's good. Okay, so we're just creating, we're loading the environment variables into the shell session by running source.env. Then we are giving our service account access to Gemini by running this command. We give it access to Vertex AI, which gives it access to the Gemini API in Vertex AI. So now we can call, if we don't do that, our agent won't have access to Gemini, basically. And now we are going to copy paste this and run the deployment command. Now, this might take a few minutes. I'm not sure if we will be able to see it before the time ends, but we'll try. Hopefully, you're able to get here and run this on your own. And while it runs, I'll stay here. I will explain what it does. So ADK has its own ADK deploy command on Cloud Run. So it has this nice integration between ADK deploy Cloud Run. You provided the project, the region, the service name. With UI basically means that you will have a UI for your agent that you can interact with. And sometimes Google Cloud Shell just wants you to authorize again, which is pretty annoying. I'm sorry about that. Anyway, so this is the deploy command. Why do we have UVX here? Because we are using a deploying command that is defined in the Google ADK framework. And we haven't, in this terminal, we haven't defined Google ADK. We defined it in our container, but not in this environment in the terminal. So instead of pip installing Google ADK now here, we can just do UVX from Google ADK, which just runs it on the fly and allows us to use this ADK deploy Cloud Run command. And what this does, it reads our code, it builds our code, and actually, if I don't know if you noticed, but this time we didn't even write a Docker file. So this command actually creates the Docker file for us. We don't need to do it. It understands, what Docker file is required in this case, creates it for us on the fly. You can see creating Docker file, and you can see that it's deploying our agent to Cloud Run. And it asks us if we allow annotated invocations to the Zoo Tour Guide. And actually, I'm not sure if I answered this correctly. So we might need to run an additional command to allow this later. Because we want to test our agent. So we want our agent to be able to get unauthenticated invocations. So I might need to do a fix for this one. And while we wait, maybe I'll bring the code for that fix in case we don't have time. And feel free to drop any questions in the chat if you have any. But in general, if it asks you that question, in case of debugging, just say yes. In case of just prototyping, just say yes. Okay, so if we have access issues to our agent later, what we could do is just expose the service to unauthenticated calls using this command that I just put in the chat. Basically add IAM policy to Zoo Tour Guide that all users can invoke it. And then
can you just make sure that you send the message to everybody and not only to the hosts and panelists, because I cannot copy it. You just have to select in the
thank you. Yeah, sorry about that. Yeah.
Before that, I didn't want to disturb you. So when you send, I just copied it to everybody. But this is too long.
How do I do it? Oh, okay. I see now. Everyone. Okay. Yeah.
Exactly.
Sorry. Okay, now I put the command here. Okay. Let's see. Now my service is actually deployed already. Let's see what happens here. If I try to run it, you see it's forbidden because I run it in an authenticated manner. So let's see if I try to wait. I tried to run the command I just shared with you all. Oh, I'm not able to copy paste it. Just a sec, I will copy it again. And we will conclude with that, but I just want to show you at least that we are able to see the UI for our agent. Okay, now I'm going to try and okay, so this is the UI of our agent. Oh, there's an error. I actually saw this error before, but this is something really cool. So I just, okay, we'll finish with that, but I'll just tell you that this is something new that I think I saw it like yesterday and I wasn't sure, but I guess LangChain changed something in their package. And it now requires us to actually, and how I debugged it, I used Gemini CLI. I just gave it the error and it told me that I need to add a long chain to our requirements text. And then if you test it again, it should work. So again, we're out of time. I don't want to do it now with you, but I just want to tell you that you can also put it in the Gemini CLI here and see that this is what Gemini CLI will ask you to do it for. It will ask you, hey, I can do it for you. We'll add it for you. Anyway, we just need to add it to the requirements text and just deploy the agent once again and run it. With that, we'll finish here. You can continue following along with the lab 2. We did most of it. Play around with it, try to make it do fun things, add things to your MCP server, to your agent, get it to tell jokes. And enjoy. I mean, you got some free credits to Google Cloud. You get basic understanding of how to build MCP server and agents. And I hope you had some fun today. I hope you have some inspiration to go and play and feel, very welcome to connect with me. If you have any questions, I'm here in LinkedIn. And it was a pleasure talking with you all. And I hope you had a good time.
Yeah. So, okay, so I see that there are some reactions already in the chat and also in the Q&A. So, yeah. So I can say, I think that I can speak. I can say that I've been in a lot of webinars, and I can tell you that it's not trivial to keep the majority of people alive and kicking throughout the session. Especially, I unfortunately I didn't follow you. Because I was really busy in seeing that everything works well, that everybody gets responses. But I definitely I'm happy that it is recorded, that I can follow it in my own slow pace later on. But I think it was really amazing, Shir. Toda raba raba in behalf of our community. We have it recorded. I'm pretty sure that many people will want to rewatch it or watch it and follow that in their own pace. And it's yeah, and toda raba, really appreciated.
Awesome. Thank you so much, Chen, for the opportunity and for creating this wonderful stage for the community to connect and learn together. We have a lot more resources, by the way, if you want, with the same link. If you just add -2, -3, -4, -5,
okay.
Those are all different labs step by step, just like this one that you can follow. So feel free to learn. We're also doing fine-tuning. We're building more agents there. So we're doing different things. And just stay connected. We do a lot of cool things.
Okay.
Happy to meet you all.
It seems like that. And a lot of people asked me during the session about the recording. So yes, everybody registered will get the recording. We will also make it available in the IMVC website, and we are going to follow up with an email. So Shir, certainly if you have any things you want to communicate to the guys here, feel free to send it to us, and we will send it over to everybody registered. And yeah, thank you so much for the effort, and have a nice day further. And we are here waiting for you to come back.
Awesome. Thank you. Have a good night.
ביי
Bye-bye.
ביי, להתראות. תודה רבה לכולם.